So the intention of this talk was to look. So I did some. So I'm a Pluralsight author. I'm creating Pluralsight courses, and I did a couple on C#, starting with C# 9. But if you look at the features in C#, it's like, yeah. So some of them are like, yeah, well, it's great to have, but others are like, yeah, kind of niche things. So I was like, okay, let's do a session where I not try to cover every new feature in C#, but just the ones that can actually be used in practice, right? So that's kind of the idea behind this talk. So I'm going to talk about new features from C# 9 onwards until C# 12, which just came out yesterday. But I'm just focusing on the practical things. So the things you can use on a day-to-day basis as a developer. Sounds like a plan? Cool. My name is Roland, by the way, Roland Guijt, and I'm from the Netherlands. And well, I'm doing all kinds of stuff. And that's about it for my introduction. So this session is about useful additions, and these are of course arguable. So it's kind of my opinion that this is useful. So don't expect a full coverage around C#. I'm assuming C# experience, of course, so that you know at least something about C#. And this is about code examples. So I have a few slides, like this one, but the most part will spend inside Visual Studio, just looking at code. Maybe I do some live coding, but I have to do a little prayer to the demo gods then. But we'll see. All the code I'm showing is in a GitHub repository. You can just download it. So the link is in the slides. I will show you the link afterwards too. All right, so that's the plan. Now let's dive in. So what are these new features? I've identified these major features in C#. And there are actually kind of 4 categories and 1 miscellaneous category. I call that syntax, but that's just stuff that didn't fit into any other category. And I didn't want to create too many categories. So syntax just means miscellaneous topics, basically. Syntax, all kinds of stuff, namespaces, immutability, lambdas, and pattern matching. These are the main topics. So if you look at this, do you have one particular category that you really want to cover? You say, yes, I'm in the room for this topic. I want to know about this. Which category is the most, stands out the most for you? Pattern matching or namespaces? Any particular preference in order? No? Okay. No interaction. Okay. I can do that. All right. So let's start with Punima. What topic are you the most interested in?
Put me on the spot, didn't you?
Yeah.
Let us talk about primary constructors.
So primary constructors are just do syntax. Yeah, sounds good. Sounds like a plan. All right. So I have one giant solution, and this solution is not meant to run, right? It's just full of code examples. There's not. I think I have one exception with an application, but the rest is just meant for code examples. Not meant to run any project. Okay, so when we look at syntax, we have these. These correspond to the slide. Everything went well in the preparation, right? Okay, so let's start with number one, top-level statements. So with top-level statements, so the thing is, Microsoft wanted to simplify things. So in earlier .NET versions, before C#9, you always had to write this. Right? So you had to create a class called program with a static void main. And what the CLR would do is just search the assembly for a method that is called main with a capital M, and pass the arguments to that method. So that's the bootstrap method for your application. But it involves some ceremony, right? You have to know what a class is. You have to know what a static is. You have to know what main is. So for beginners, this is maybe not too straightforward. So they decided to just get rid of that. And now you can just have just one file in your project that has top-level statements. What does it mean? You can just start writing code just like this, as if you were not in a class at all. So you don't have to write a class, you can just write code. Now this is great. I don't know if it's, to be honest, I don't know if it's a real improvement, because when I teach people C#, I always tell them, yeah, you have to have a class and you have to have a method, and inside there you can write code. And now suddenly it seems that you can write code just out of the blue. But anyways, when you create a new project now, you can actually choose if you want top-level statements or not. So if you do a file new project, and we do a console application, for example, and choose a name, then you have the possibility to use top-level statements, and the default is that it's on. If you uncheck this, you will just get the main method again. So it's a choice. There are a couple of rules for top-level statements, for the top-level file with statements. You can add methods if you want, so that's no problem. You can just add some kind of function. So you can say, okay, I want a void, say hello, and that works. And you can just call that. That's possible. But you have to remember that this code is actually behind the scenes. It's translated into this, right? So in IL we still have a program class with a main method. You can even define types. So you can just say, okay, I want a class person here, and that class person has a property, and now we can just new up the class. P is new person. That works too. The only rule is that you have to create the types after the top-level statements. So you cannot do the person first and then do the statements. So that's a rule. And the class itself will just be a class in a class behind the scenes. It will be a program class, and inside that class will be the class you're defining. So that is top-level statements. And yeah, you can have an opinion about it. I'm not really enthusiastic, but okay. Other thing is we have a type, the new omission here. So what you can do now is you can just say, okay, wait a minute, I have well, let's do this. So for example, here I'm defining a datetime property here, and in a test method I'm newing up that datetime property. Now, the first statement is just a new instance of datetime, And instead of typing new datetime here, which still works, I can omit this type. And why is that? Because the compiler already knows the type, right? Because I'm mentioning it here. So it already knows this is a datetime. So after the new statement, you don't have to write datetime anymore. You can just omit that. And what if this is a var? Well, then it's difficult for the compiler, so we get an error. There's no way to infer this type, right? So then it doesn't work. Then you just get a compiler error. It also works with this property I mentioned. So here we have a property that has a specific type, of course. And here it works too, because we already know the type of my property. Now this is kind of in one file it makes sense, right? But if this would be 100 lines down, it wouldn't be as clear, I think. So it works, but I think you have to keep in mind that your code has to be readable, right? And obvious. And so in this case, you could think, well, maybe it's not that obvious, because now we don't know what my property is at all, right? Okay, in C#12, why did I include this? Oh yeah, it's about the new keyword, of course. So in here you can see that we use var, and we have the new with the type omission, but it still knows what type it is. And that's because of the initializer here. So we have the initializer here. It says, okay, this is a collection of some kind. So it infers that A is an int array. If you don't want that and you want something else, you can specify that too. But it infers it's a new array, it's an int array, so we can just use new with the omission again. So far, so good? Okay, next one, raw string literals. So, creating a string in C# is easy enough, but it isn't if you have things like quotes in your strings, right? So we used to have a possibility to use verbatim strings, but if you do a string like this, you say, well, let's create a string with a quote somewhere in between. Well, you cannot just write the quote like this. You have to kind of repeat that quote, and you get weirdness like this, right? So in C#, I believe it's introduced in 10, we have this ability to use triple quotes. So you can use encapsulation. You can encapsulate a string with 3 quotes instead of 1. And now I can just use a singular quotes within the string. Right? So you actually see it as it is. And you can even use interpolated strings here with the $sign and just create an expression inside the string. So that's convenient. But another thing you can do is you can actually create multi-line strings. So here we have a piece of JSON. And inside that piece of JSON, we have, of course, there is some kind of indentation going on. So I'm indenting this string here. There's a gap in between. So, and the cool thing is, when you use the triple quotes, the compiler will recognize where the indentation is. And it looks at the closing 3 quotes here, and it just sees, oh, the closing 3 quotes are there. So this is the actual indentation level of the string. So when we right line this JSON, it will have this. It won't have this indentation you see here in the code. It will just have it will start at the beginning, right? And you can also use, there's another difficulty here, because this is JSON and it uses these curlies inside the string. And of course, curlies are used for things like this. So if we use string interpolation, we already use these curly braces, right? So how can you compensate for that? Well, you just use $$ here. So if you use $2, you say, okay, I want to use 2 curly braces to insert an expression. So this expression here has 2 starting curly braces and 2 ending curly braces, and that indicates an expression. And you can do 3 as well. If you do 3, you see that this becomes a normal string now. Because now I have to indicate an expression, I have to use 3 curly braces. So in that way you can still keep a readable string while using all the nice features in C# that are available. All right. Cool. Next one, generic math. Now it gets a little bit more complicated. The thing is that now, so the bottom generic math, these features all have these nice names, right? But it comes down to the fact that numeric types in C# can now be used in generics. So normally an int is a totally different type than as a double, right? So so you could create, let's say we have a method here. It's called add all in this case. Normally you would write code like this. So you say, so I want an int, an add all, and what I'm accepting is an int array, and then I have some implementation, right? And that works. But now I have a double, and I want to have an add all functionality on that as well, right? So then I have to create another function basically, because double has nothing in common with an int. There's no way to make this generic, right? So potentially you would end up with many such methods to just support all these numeric types in .NET. So instead what we can do now is we can create a generic method and say, so here this is a generic method, right? We use t as a generic type parameter. We return t as the return type. And we accept a t array as the input, as the parameter. So in other words, when I fill this, so if I say this t is an int, this t will change into an int behind the scenes. So every t here becomes int. So we get int, add all, int array values, etc. Right? So that's the basic thing about generics. But with generics, we can also add a generic constraint. So in this case, I'm telling the compiler, well, T has to implement an interface which is named iNumber of T. Now, this interface is new, and now we can. So every numeric type in C# now implements this interface. You don't have to do anything for that. It's just part of the framework now. And when we look at this interface, we see all kinds of stuff. We see this is an iNumber of T self. So there is a T self. We have all kinds of methods available inside that interface. So that means that on all numeric types you can now call these methods, because all numeric types implement the interface. And it also derives from a lot of interfaces. And one of these interfaces, wow, there's a lot, is iNumber of self. Yep. So it inherits from this guy as well, and this will just have more stuff. And one of the things that it has, for example, it has this isNegative function. So we have isNegative, it returns a Boolean, so are you negative or not? And it also has an isZero function somewhere. Not here, but somewhere in the hierarchy there's an isZero function to check if the value is 0. Remember, when we're using generics, we cannot access the actual value of the generic type, right? We just have the interface. So when we go back to the example, where is it? This one. So inside this function, we don't know what t is, and we cannot access the value of t. We only know that it is of that particular interface, right? The iNumber interface. So if we want to check if it is 0, for example, we cannot just test for 0, right? We have to use the interface in order to test for 0. So that's why in iNumber all this stuff is implemented. For example, you can say t.0. And behind the scenes, it will check the numeric value for the actual 0 value. Okay? There's one, there's max, there's ABS. And of course, the operators are overloaded. So you can just say, you can iterate over these values and just add them to another value. That's also possible, right? So in many cases, this could turn out handy. You can also use extension methods to some degree, but this is more powerful. Still good? Great. Next topic. Required. So here we have a class person, and this person class has a property which also features a new feature in C#, a relatively new feature. It got introduced in C#9. It's called an init property. So what does it mean? It means we can set the value for name during construction. So when we are constructing this class, we can provide a value, and after the fact we can't. So in this case, I have an object initializer, and when I now do p.name equals John, it's not allowed because it's an init only property, right? So that's great. That's cool. I like that. But what if I want to omit this value? So, for example, I just want to create a new person class. That works too, because it's an init only property, but it's not required to initialize it, right? You can set the value during initialization as an option. And if you want to make that compulsory, you can now use the required keyword. So when I now construct person, it will tell me required member person name must be set in the object initializer, in this case. It also works with just a set property. That works too. Same thing, right? But now I can still not. Well, I can put in a name, but I still get an error because I have to provide a value upon construction. When I construct it, it has to have a value. Okay. Also, yeah, so you would maybe say, okay, wait a minute, I can also do this, right? So I could say, well, just introduce a CTOR here, accept the name as a parameter, and then put it in here. That's a pattern you've probably used 100 times already, at least, right? So you can do this, but and then provide a name, of course, as a constructor parameter, like this. And this works too. Now it's required as well. But the downside is, besides the fact it's quite a bit of code that we have to add to initialize all the stuff, we lose the default constructor. So in C#, and that's not new, it's been there always. As soon as you create a constructor for yourself, you write it yourself, the CLR is like, okay, you can do better. I won't create a constructor for this type at all. You just do it. So you lose the parameterless constructor in this case. And you can just add it yourself again. That's possible. More lines of code, more logic. But the downside is when you lose the default constructor, you can't do things like serializing, in particular deserializing the object anymore. So required makes it easier, basically. Okay, let me reset this. Because, yeah, I know myself, right? I've done too much. I'll do it later. Okay, next one, auto default structs. So this is a short one. In the past, when you create a struct, you have to initialize the property values because it's a value type. Struct is a value type, and all the properties you define inside the struct, you have to initialize them. That's just the way it works. So before C#10, you had to just say, do at least this. If not, you will get a compiler error. And now, when you omit some value, or more values, that's also possible. Leave out the constructor entirely, that's also possible. The compiler will just assume, okay, we just gave x and y the default value for int, which is 0. Okay, so that's also pretty practical. Now we get to the C#12 features. So first of all, we have the primary constructor. So this looks really weird, right? We have this class now that can take parameters. So it seems, right? This is the primary constructor. And what does it mean? It means that this test class will get a constructor with these two parameters, basically, automatically. So now when I new up a new test class, where is it here? I have to provide the two constructor parameters. I didn't explicitly write a constructor anywhere, but because it has this primary constructor here, I have to provide these two values. I cannot create it anymore. I cannot instantiate it without these two parameters. That is, in itself, it's cool, but there are some buts. You have to know what first name and last name are, what they are in the class, right? To be able to work with them. So, first of all, these two are not members of the class. So they are not fields by default, and they're also not properties of the class. So it works in a weird way. So, but as soon as you change the value, it will store the value in the class, and then it will have a presence in the class. Not as a direct member, but you can just access it. So, for example, here we have a public string full name, which uses string interpolation, and it uses first name and last name. Now, first name and last name are not members of the class, so these are not references to fields or properties, but they are constructor parameters, and I can use them in initializers, like the initializer here for the property. Okay? And here, in this method, we say we're changing last name. So we're still using last name, and we're saying, well, last name has to be something else. Okay? And now the CLR will say, okay, yeah, so I have to store this value now. So it creates a field for this value, and it will store it in the field. You don't see the field, you cannot access the field because it has an unreadable, unknowable name, but there is a field. So it's a little bit weird, but it works. Okay, now, when we have, go ahead. First name, space, last name. Oh, yeah. That's a good question. So initially it will be this, first name and last name, but when this method is called, it will change. Because now this will be stored, and it will recognize, okay, now it's stored, so last name here will be the stored value. Yeah, this is a static value, but yeah, it will, yeah. I would not get this into production, right?
It's a question for interview.
Yeah, exactly, yeah, that's a good one. Okay, you can also use inheritance. So here we have a derived class that inherits from test class. You can just do that, but you have to repeat all the primary constructor parameters. So first name and last name you have to repeat here, and then pass them on to the primary constructor of test class. And you can add new stuff if you want, but you have to pass it on, right? Then we have collection expressions. So in C# we can now do something like this, and it looks very natural, especially when you use the JavaScript, right? But we can actually now use the block, how do you call them? The straight what's the name for that? Okay, you know what I mean, right? These things, just brackets, yeah. To initialize the array. And this can also be used in combination with the omission of new, right? I showed you before. So here we have an int array A, which has a certain sequence of characters, and we have a span. And we can even use, and another new feature with this is that we now have a spread operator, also just like in JavaScript. So we can have 3 arrays, and we can now use the spread operator here, 2 dots, and mention this array. So what it does is it will take apart this array. It will take the individual elements of the array, it will put them there. So this single int array will just have a sequence of characters from 1 till 9, and not 3 arrays. When you leave out the dots, it will be just 3 arrays, right? You get an array of arrays. Cool. Yeah, it also works with parameters, of course. So when we have some method total with an int array, we can just pass in the array using this syntax now. So so we can omit new here. So that's one feature we're using here, and we can use this new collection expression syntax. It looks a little bit weird if you're not used to it, but it's totally fine. You can also say, okay, in combination with this. So now it's not an int array we're expecting, it's an IEnumerable of int. You can also put in a list of int here. It also works. It works with all collections, with everything that implements IEnumerable of t, basically. So you can say, I'm initializing an array, and I'm calling total e with a couple of numbers, and array with a spread operator. That works too. So we get this sequence plus that sequence. That is now accepted in this parameter. Great. So that was syntax. Took a little bit longer than I expected. We don't have time to cover everything. So now you have to make choices. Sorry, pattern matching? Okay. You were the first, so... Okay. So what is pattern matching? So we had the switch statement for a long time in C#, right? So you could just write switch, event entity, event entity dot market cost type, that one. Marketing cost type, and then say, okay, case, cheap, do this, etc. So this is the switch statement. We already had that, but we also in C# we now have the switch expression. So instead of this, we can now also do this. So we can say price plus is event entity market cost type switch. And now we can test the marketing cost type for certain values. So when it's cheap, it's 8. When it's moderate, it's 10, etc. And when nothing applies, then we throw an exception. So that's basically what pattern matching is. We want to test some values and then produce another value. So this is all cool. But it gets more cool when we use the different patterns that are available in pattern matching, right? So, for example, we can say we can test a certain value. So here we do a normal. This is a normal switch statement, and now we can inside the switch statement we can also say case multi-day conference E, multi-day conference entity. So this will test if this event entity is of type multi-day conference entity. So this works in object orientation and with inheritance, right? And it will also check if it's not null. So in that case, we get the instance of multi-day conference entity available in the E variable. We already had a variable, but that was of a base type, and we want it as the derived type. And we get that derived type available in E. So now we can access multi-day conference entity object using E. Okay, so that's one thing you can do. This is called the type pattern. Sounds simple. So a more complex thing is that you can now do, say, price plus is E number of days switch. And now we can use the greater than and lesser than operators on this value. Now that seems like logical, but it's comparatively new, because before C#9 you had to do this. You had to create a variable and then use a when clause and then test P, etc., etc. Work too, but this is way more readable, I think. And you can also use it with together with the conjunctive pattern, and that's just a fancy word for using and in your expression. Right, so you can test with, things between values. Okay. What else? Yeah. This, yeah, it's not really important. We also have the not null pattern. That's a minor pattern. You can now say case not null, and that also works. When you just do a simple null check. So if you say if event entity is not null, that works too now. So that's more readable than doing the previous stuff. All right, property pattern. So here we have the property pattern. So what it's also like TypeScript almost, if you're familiar with that. So here we create a person with some address, and now we can say if P is person. So this particular part will check if person is not null. That's the first check. And second part, of course, is the check if P is the person type. And we can do more. We can actually use pattern matching to see if this person conforms to this shape of the object. So we can say, okay, we know it's a person, but now the city property in address has to be Amsterdam. And only then this if statement evaluates to true. In addition to that, it will make this person available in a variable again. And we can just use it in the block scope of this if statement. List patterns. These are new in C#11, I believe. So what we can do now is, so we're using the C#12 syntax here to indicate a collection. And in this particular example, we can say, well, when int looks like this, then there's a match. You can also use a discard pattern. You can also say, okay, I want the first three elements to look like this, and the fourth one, it doesn't matter to me what it is, but it has to be, it has to have 4 elements, right? I don't care about the value of the fourth one. And you can also use this spread operator to say, okay, it has to start with 4 and 6, and the rest doesn't matter. This also means that it can be longer than 2 elements. It can be 2 elements or more than 2 elements. It doesn't matter how many elements there are in total. You can use this in combination with the var pattern. So now we have the rest available in a variable. So rest is now available inside this this block. So with a handheld microphone, live coding gets even harder. You can also use the relational pattern here. This is a slightly more complicated example. So we can say, so this refers to the first element. So we're saying here the first element has to be less than 5. The second has to be more than 6. The third doesn't matter, and for the rest I don't care. Okay, it also works with a read-only span. Okay, cost type. Cost type? No, that was it. The next topic. What about namespaces? Is that a good topic? I kind of thought it was too long for this talk, but I just wanted to give you all the code examples. Okay, namespaces. There are, first of all, we have the file scope namespace. So here we say namespace, and then a namespace name followed by a semicolon, right? That wasn't possible before. Before we had to just use curlies to indicate the scope of that namespace, right? And that used up vertical space because everything here had to be indented, right? Now I can just, but with file scope namespaces, this basically means this whole file, so in this case filescope.cs, will use this namespace, right? So now I don't have the vertical space. I can just start every type on a new line and be done with it. The only downside is we cannot nest namespaces. I cannot declare a namespace in the old, I cannot type now, but I cannot define a namespace inside this namespace. It's just one namespace. So if you want another namespace, you have to create another file. Okay? Implicit usings, cool too. So with implicit usings, you can, in the project file, you can enable implicit usings, which is by default enabled now in when you create a new template from in Visual Studio Code. And when you do that, you see that these there are certain namespaces. Save it first. Yeah, Okay, took a while. Certain namespaces get grayed out. So in this case, system gets grayed out. I don't need a using statement for that anymore. And that's because it assumes that there are certain usings present by default. So let's see. Because I had a slide for that. Yeah. So what kind of namespaces are there, are included, and it depends on the SDK you're using. So if you're using the normal, you're creating a console application using Microsoft.NET SDK, and these namespaces are included. When you create an ASP.NET Core application, you use that SDK, and in addition, other namespaces are included as well. So in this case, when I go to the namespaces project, you can see the SDK here, because this is a console application, right? So it depends on this setting which namespaces are included with the implicit usings. And you can also modify these. So you can just say, okay, I want to remove a certain namespace from the implicit usings. In other words, I want to have an explicit using for this namespace. And you can also add here. You can add other namespaces that are, is it add or is it, let's see, include. You can add namespaces to this implicit using list as well. I think I have to stop talking. Just one quickie. So we have this, so we also have global usings. So instead of having the implicit usings, we can also say global usings. For example, we can say here global using share.enums. And this means that all files will implicitly get this namespace as well, this using as well. And this is a little bit dangerous. I wouldn't recommend to use this all over the place. Just create one file with all your global usings. That works. And also, if you use it in combination with implicit usings, I would recommend implicit usings for Microsoft and system namespaces, and global usings for your own namespaces, just to keep things apart and keep things logical and readable. Just a suggestion. Okay. With that, thank you very much and have a great conference.